Angles. Let's discuss the basic labeling of angles. An acute angle is an angle whose degree measure is between 0 and 90 degrees. An obtuse angle is an angle whose degree measure is between 90 and 180 degrees. Right in the middle of the two is a right angle, an angle that measures exactly 90 degrees. Right angles are marked with a square at the angle's vertex. A straight line is a 180-degree angle. It's very important to remember this, as you'll see when we get to the practice problems. There are 360 degrees in a circle, or a full rotation. The sum of four angles formed by two intersecting lines is 360 degrees. The sum of the measures of the angles on one side of a straight line is 180 degrees. When two lines cross, the angles opposite of each other are called vertical angles, and are always equal to each other. As you can see in the illustration below, the angles across from each other are equivalent. Alternatively, two angles are supplementary if they make up a straight angle, meaning they add up to 180 degrees. Vertical angles are ones across from each other. Supplementary angles are ones that are next to each other. Angles are complementary if they make up a right angle, meaning they add up to 90 degrees. Take a look at the illustration below for a visual example. Let's take a look at the practice problems to put these principles into action. If a wheel rotates 40 revolutions per minute, through how many degrees does the wheel rotate in 3.3 minutes? Let's break this down. We know that the wheel rotates 40 times per minute. We're being asked to calculate how many degrees rotates in 3.3 minutes. So to solve this one, you need to set up a proportion. We have 40 revolutions per minute, so that will look like this. 1 minute over 40 revolutions. And then on the other side, we have 3.3 minutes, and our variable will be below it, as it's the value we're trying to determine. So think back to the proportion lesson and how to solve them. Cross multiplication. So we'll have 40 times 3.3 minutes equals x. Use your calculator to determine that 3.3 times 40 is 132. So that's how many revolutions there are in 3.3 minutes. But remember, the question isn't asking for how many revolutions. It's asking for how many degrees. So, as we know, there are 360 degrees in a circle. So all we have to do is multiply 132 by 360 to determine the degrees. Plug it into your calculator, and you'll see that it's 47,520 degrees. That's our answer. In the figure below, two parallel lines are intersected by two transversals that intersect at point C. Two angles are marked. What is the measure of angle DCE? Take a look at the figure below and take note of the angles, specifically angle DCE. The best strategy for angle problems like these is to work in reverse. We know that to find angle DCE, we'll need to know angle ACB, and to get angle ACB, we need to know the measure of the other two angles in the triangle. We know the measure of CAB is 55 degrees because it's vertical to the 55-degree angle that we're given. We can determine the angle supplementary to the 120-degree angle by subtracting 120 from 180. That gives us 60 degrees. This is also the measure of angle CBA, as it's vertical to the 60-degree angle. So now we can add up 60 degrees to 55 degrees and get 115. We know that the measure of angle ACB is 180 minus 115, because there are 180 degrees in a triangle. 180 minus 115 is 65. And that gives us the measure for angle DCE as well, as we know that opposite angles are congruent. So there's our answer. 65 degrees. Let's look at one more practice problem from the GRE. With the given figure, what is the relationship between column A and column B? For this problem, we know that x's vertical angle will be congruent with it. So let's move it down. Let's try to set up some equations that will show the relationship between the angles. We know that all of the angles in the triangle will equal 180 degrees. So we can have x plus y plus z equal 180. We also know that y and v are supplementary to each other. So y plus v equals 180. Since they both equal 180 degrees, we can set the equations equal to each other. And since there is a y on both sides, you can cancel them out, and you're left with x plus z equals v. Thus, the columns are equal.